Okay, welcome to section 3 of the course, Networking. Our first video was going to be about exploring VPC endpoints and using Route 53, the AWS DNS. So what are VPC endpoints? So VPC endpoints allow access from your VPC to AWS services, such as S3, without having to pass through an internet gateway. So here we have an example. A very simple example where we have a VPC running within AWS and a private subnet with an EC2 instance wants to gain access to resources on S3, an S3 bucket, resources within. If we didn't have a VPC endpoint, the EC2 instance would have to go through its route table, out through the internet gateway, out to the internet, back into AWS, get the resources from S3, back out through the internet gateway, route table, back to the EC2 instance. When we introduce VPC endpoint into the picture within our VPC, it gets much simpler. The EC2 instance wants to gain access to S3, it goes through its route table. The route table has an entry for the VPC endpoint, which allows access to S3, gets the resources back through to the EC2 instance. We have never left the AWS environment. So this is a way to use VPC endpoints, a very simple way, to make your application more secure, because you don't have to send your traffic out through the internet to interact with your AWS resources. So VPC endpoints can be used in software as a service solutions or SaaS solutions. So VPC endpoint allows SaaS providers to offer their services to their SaaS clients, all within the AWS infrastructure. So similar to the previous story, we have an EC2 instance running within a VPC where a customer wants to use their SaaS provider. They create a VPC endpoint and they connect that VPC endpoint to their SaaS provider's network load balancer, which provides their services. So you have your customer's VPC connecting to their SaaS provider's VPC, all within the AWS network infrastructure, never leaving AWS to go out to the internet to interact with their SaaS provider. So similarly, this is a much more secure environment to integrate SaaS products in with your application, because you are keeping all of your network traffic secure within the AWS environment. As I said, all traffic remains within the AWS network infrastructure, and SaaS consumers can integrate with SaaS providers without requiring their traffic to cross the public internet. And also, this setup assigns a private IP address to the endpoint that can be accessed without touching the public network. So a very nice way of integrating your SaaS provider into your software solution in a very tightly integrated way. So you can also use VPC endpoints to integrate a SaaS solution. So say you are a SaaS provider, not a consumer, but a provider, and you want to build your SaaS service so that it has multiple pieces, some of which might be partner SaaS solutions or open source SaaS solutions. So you can use VPC endpoint to integrate with other third-party providers. So say you are SaaS solution A, and you have your SaaS product, and you want to incorporate SaaS solution B. So you can do that through a VPC endpoint using your network load balancer. But maybe SaaS solution B also incorporates SaaS solution C. And so they do the same thing. SaaS solution B uses a VPC endpoint to integrate with SaaS solution C. So all of this is all, once again, within the AWS network. So all traffic remains within the AWS networking infrastructure. And this obviously reduces risk and increases efficiency. Risk is reduced because you don't have to go out over the internet with your traffic. And efficiency, same reason. It's all within AWS. It's all within AWS's high-speed networking infrastructure. And it makes service integration more secure. So that was VPC endpoints. Now let's talk about Route 53. So what is Route 53? So Route 53 is a highly available and scalable cloud domain name system, or a DNS, and it's built around a web service. And I have a simple example here of how you might use Route 53 It's basically a static website on an S3 bucket with CloudFront in front of it, and your Route 53 hosted zone is defined for your domain. In this example, I'm calling your domain yoursite.com. And so when users make a request for yoursite.com, it goes through the Route 53 DNS web service, which then routes the traffic to yoursite.com, and it has an alias record, which we'll see in the lab. It allows you to point yoursite.com to your static website on your S3 bucket. And you front that with CloudFront so that users around the planet can get quick access to your static website using CloudFront. And we'll talk about CloudFront later in the course. So this setup, using a simple Route 53 connection, connects user requests to infrastructure running in AWS, such as an EC2 instance, load balancers, or even an S3 bucket. You can also be used to route users to infrastructure outside of AWS. So you can use Route 53 as a DNS to route your requests to resources outside of AWS, maybe in your data center. Traffic flow. It's a cost-effective global traffic management using Route 53. You route end users to the best endpoint for your application based on geo-proximity, latency, health, and other considerations. So you can define your traffic flow with route configurations within Route 53. And I have several examples here to show you. The first example is Route 53 weighted routing policy. So several routing policies. Here's the first one. So with a weighted routing policy, we split the DNS traffic across available resources based on predefined weights. So you can see here, we've got our users, they're interacting with our domain, and we've decided we want to route 70% of the traffic to our US West region and 20% of our traffic to our US East region. So we have our application split across two regions, and we've decided to use a weighted routing policy. So Route 53 responds to DNS queries by splitting the DNS requests based on weighting you define. Next up, Route 53 latency policy routing. So with latency policy routing, you provide low latency application response time based on user proximity. So here you can see the example. We have Asia Pac users or Asia Pacific users coming to our domain, and we are going to want to route Asia Pac users to the Asia Pacific region. And you'll see that for that region, the response time is 20 milliseconds. If we routed them to the US region, it would be 500 milliseconds. So what you do is you define a latency routing policy where Route 53 responds to DNS queries using the lowest latency path. So Route 53 figures out that this is an Asia Pac user, routes them to the Asia Pac region, not to the US region. Next example, failover routing policy. So a failover routing policy creates an active-passive configuration. So this is an example of how to build a disaster recovery solution using Route 53. So users connect with your domain. Normally, 100% of the traffic goes to the active region, the US East region. And there's a standby region, which is getting 0% of the traffic. If something happens to the US East region or the application or the infrastructure there, and the health of that application becomes compromised, Route 53 will route the traffic over to the standby region. And this is done all within Route 53, defining a failover routing policy. So one site is active while the other is on standby as a DR site. All right, the last policy, geolocation routing policy. So with geolocation, you route traffic based on the geographic location of the requesting DNS query. So here again, we have Asia Pacific users or Asia Pac users and US users. And we have a US region and we have an Asia Pacific region. So when an Asia Pac user makes a request to our domain, they get routed based on their location to the Asia Pac region. And when a US user makes a request to our domain, they get routed to the US region based on the geolocation routing policy within Route 53. So we send our DNS traffic to resources in the region where the request came from. So Route 53 figures out where the request is coming from, and it routes that request to the closest geolocation region for our domain. The main benefit of the geolocation policy is to allow you to provide content to your users in their local language.